Let us take another similar example of arithmetic progression. If the sum of p terms bq and the sum of q terms bp, find the sum of pq terms. Now the formula for sum is n upon 2, 2a plus n minus 1d. So here it is, q is equal to p by 2, 2a plus p minus 1d, and similarly p is equal to q by 2, 2a plus q minus 1d. Now solving these equations, I am cross multiplying by 2 by q is equal to 2a plus q minus 1d, and in first equation 2 by p, 2a plus q minus 1d. Subtracting both the equations, we get 2 common. P by q minus q by p is equal to q minus pd. Now further simplifying it, we get p square minus q square upon pq, q minus pd. Now we can see that it is a square minus b square, which we can write as a minus b, a plus b. So by doing this, we get the difference as minus 2 p plus q by pq. Now substituting this value in our first equation, q is equal to p by 2, 2a plus p minus 1 into d. d is minus 2p plus q upon pq. So we get 2q by p minus p minus 1 minus 2p plus q upon pq is equal to 2a. We are clearly seeing that 2 is common. It will be cancelled out. Taking LCM pq, we get q square plus p square plus pq minus p minus q. This is our A. Now taking out the sum of pq, which is pq by 2, 2a plus pq minus 1d. So pq by 2, 2 into a is q square plus p square plus pq minus p minus q upon pq plus pq minus 1d is minus 2 p plus q upon pq. Taking 2 common, we get pq common. We get q square plus p square plus pq minus p minus q. Solving this, pq into p is p square q plus pq square minus p minus q. We will change the sign now. cancels out. We are left with p square plus p square q plus q square minus pq square plus pq. If we take, this is minus, if we take p square common, we get 1 minus q. Q square common, we get 1 minus p plus pq. This is our final answer.